All right, everyone, we are live. Good morning, good afternoon, good evening, whatever time it is for you. My name is Jim Pfister, and I'll be moderating Extending Storage to the Edge, how it should affect your storage strategy. This is a live webcast sponsored by the Storage Networking Industry Association, SNIA, and our Cloud Storage Technologies Initiative. Like I said, my name is Jim Pfister. I'm principal of my own company, The Decision Place. I will be moderating today, and with me today are two very knowledgeable presenters, both from IBM. First, Erin Farr. Say hi, Erin.
Hello.
And Erin is a senior technical staff member with the CTO office at IBM Storage. And also Vincent Sue. Say hi, Vincent.
Hello, everyone.
And Vincent is a vice president, IBM fellow, and CTO for storage and software-defined infrastructure at IBM. We've got, like I said, these are two great presenters, and I expect that we're going to have a very lively conversation. A couple things about the Bright Talk user interface for those of you that are unfamiliar with it in the audience. You can see that there is a button underneath that will expand to full screen if you want, so that you can see the slides a little better. And we've got some pretty interesting animations, so you might want to do that. You also have the ability to download a PDF of the slides, and that is available to you as well. And then note also that question button. Feel free to ask any questions. In fact, we already have one in already that I'll throw to Erin when we get started. So feel free to ask questions, and I will insert them as appropriate. And if I can't get them in the flow, then we'll answer them at the end. We will also be doing a Q&A blog on the SNIA Cloud Storage site, and for questions we don't get to. Just so you know, if you're unfamiliar with SNIA, we are 180 leading industry organizations, about 2,500 active contributing members, and we reach 50,000 IT end users and storage professionals worldwide. You can learn more at snia.org/technical, and you can follow us on Twitter if you believe in that platform. What SNIA does, and what SNIA Cloud Storage Technologies does, is we focus on educating vendors and users on cloud storage, data services, and orchestration. We support and promote business models and architectures. Both those open standards defined at SNIA and defined by other open standard organizations. We really focus on hyperscaler requirements and how to incorporate them into standards and programs. And we collaborate with other industry associations, again, to make sure that this is an open industry that's developing ahead of us. Now, what we are not are lawyers. I don't think any of the three of us here on the conversation today have any significant legal background. So we're not giving you legal advice. This material is copyrighted by SNIA, and then also with a shared copyright by IBM on quite a few of these activities. But the member companies and individual members may use the material in these presentations under certain conditions, and you can see them there. But this is a project of SNIA. So again, we're not offering you legal advice. There's no warranties expressed or implied. Use at your own risk. And what we're going to cover today are some edge computing use cases and driving additional patterns of data movement. So we're going to talk about some of the challenges associated with these use cases. We're going to talk about some considerations for distributed cloud storage architectures. And we're going to have a nice, lively conversation. So what I'm going to do is I'm going to turn it over to Erin. And Erin, I'm going to kind of pass this to you. The question is a little open-ended. What is the core principle of edge computing technology? But talk a little bit about edge computing and what you at IBM really see as some of the core things that you're focusing on. And I'm sure we're going to see that coming up in the use cases as well.
Yes, and in fact, I think I have a slide that will best speak to that. But first, I think the short way to address that is that edge computing is somewhat of a trend more than an architecture. So I don't know that there are core principles per se because there's no standard, although there are a number of reference architectures out there, especially for different industry verticals. So it tends to vary a lot. But I think first I should level set for anyone who's not familiar with edge computing, give a little bit of a background, and that's actually what I can do next, because for today we'll go through a series of use cases along with their data movement patterns. But first, I would like to level set on some terminology, at least for the purposes of today's discussion. And I think through that, I can then better answer this question. So for today's discussion, From an edge computing standpoint, edge is simply where the data is being generated. So examples include branch offices or retail stores. They can be research labs or industry or manufacturing sites, and they can even be automobiles. But we also have our centralized location for running business workloads and for generally storing data, which today I'll refer to as the core site because it could be a public cloud, but it may also be a hybrid cloud or a private cloud or an IT data center. And for those familiar with edge computing, just from a terminology standpoint, you might be familiar with other intermediate locations such as telco or network edge and co-location sites. And for today's purposes, either of those sites can play either one of these roles. They can act as a core location for an edge site or be where you're processing edge data and communicating with the core. So this is abstracting it out so that we can simplify the discussion. And as well as some of the use cases we discussed today can also be between edge and core. But for today's discussion, we're going to keep it simple. There's basically some edge location that's generating a bunch of data, and there's some core location, which is your centralized location for your business workloads. And then also for today, when we hear about edge computing, people tend to think, and most of the articles are about edge devices, such as a camera or a fit-for-purpose device with a sensor. However, it's this aggregation of all the data from all of these edge devices that drives the need for something to live on the edge to process all that data, such as an edge server, along with its associated storage. So today, the focus for our discussion, when we talk about storage on the edge, it would be storage for the edge server, not the devices necessarily, right? And so I should also mention, and this relates to what Jim was asking, that we view edge as an extension of hybrid cloud, right? And to be more specific, some edge computing solutions have processing and data storage outside of the public cloud providers, but that are also purpose-built to work with specific public clouds. And some of these hybrid cloud capabilities deployed on edge locations can also help with some of the use cases I'm going to go through, though our focus today with these use cases is mainly around the storage software layer functionality and the data movement patterns associated with the use cases, right? So to help with the original question, for those not as familiar with edge computing, there are a number of factors that are driving compute to the edge. There are vast amounts of data at these edge sites. And in many cases, it's just easier to move the compute, meaning the applications and the workloads, than move the data. And so that's one aspect of the trend towards edge computing. But sometimes there are governance considerations, right? So in some cases, you need to keep the data where it is due to compliance or regulatory needs. For example, some data can't cross national or state borders. And security can also be a factor. I mean, making less copies of the data can reduce the overall attack surface. Cost can be a factor as well. Moving data and making copies of data can be expensive, especially over time and at scale. And then speed and performance can also come into play. Some use cases have low latency requirements like manufacturing and Industry 4.0, and processing the data at the core site wouldn't meet those latency requirements. And finally, from a business continuity standpoint, there are some edge environments such as construction sites or mining that are remote or sometimes portable that cannot always rely on connection to the core site. And these industries need the ability to support disconnected operations. So in terms of the original question around principles, I would say, edge solutions usually have most of these aspects associated with them. But I will say it does vary a lot. Your mileage may vary by industry vertical, right? Because not every industry needs to worry about unreliable connectivity, for example. Okay, and if that didn't answer your question, feel free to, ask a more specific version because it's how I interpreted it. But,
personally, I thought it was a pretty good answer, Erin.
Okay, thanks. So let me go to the next slide. So for those, so due to these drivers, here are some of the familiar patterns that we typically think of for edge. So let's just to level set, here's what I think people normally think about. So for example, you might have seen cases where you have existing workloads on the core site over here on the right, and they have data being sent in from the edge. But now these workloads are getting migrated to the edge to avoid the data movement for either better latency or efficiency or any one of those other reasons I just listed. But along with moving existing workloads from the core to the edge, there are brand new workloads that are also being created on the edge for dark data, which is basically data that just wasn't being used. And from an edge context, maybe it's because it was impractical or not possible to move it to the core. And so what's often communicated as the solution for edge computing is just to take those applications on the core site and put them on the edge, right? And our problem solved, right? But not so fast, because we are seeing some other use cases that require additional considerations around where to keep your workloads and your data. And so, for example, what happens when you have a data scientist who wants to do deep learning against the data on the edge site? Well, deep learning usually requires a GPU for faster training, and you don't have a GPU over here on the edge site, but you have a GPU over here on the core site, and GPUs are expensive, and maybe you can't afford to have them at each and every one of your edge sites. So the data scientist decides, well, I'm just going to go do my training on the core site, right? But however, the inferencing still needs to remain on the edge for faster response times. So to do this, she decides, I'm going to copy the data myself. But first she needs to talk to 3 different teams. She needs to first go to the data governance team, who manages the permission and access to the data and manages the replicas, and find out if she's even allowed to make a copy of this data from the edge site to the core site. And then once she gets their approval, then she needs a place to run her workload, right? So she goes to the cluster management team, and they manage the compute backbone, and they host compute tenants from different business units. And then once she gets that cluster, now she's like, well, now I need a place to put my data. So she goes to the storage management team, who manages the central storage and provisions storage to the compute cluster. And so then once she gets those approvals and gets a place for an environment, the data management can still be manual and error prone. So over here on the left on the edge site, we have our data of record. And again, she copies the data. So she copies the data over to the core site. And very often when this happens, she might use new file names because maybe they have dates on them, because she has to keep track. As a data scientist, she has to keep track of what data was used for which models. And then over time, doing this repeatedly, there are multiple copies of data. But because she has to keep track, she can do this, for example, in a spreadsheet and say these copies of the data were used for this model. And then finally, she performs her training with the GPU. And now because she used a GPU, it's say like maybe 8 times faster, right? So then she copies the model back to the edge site. And over time, some copies are deleted to free space. But over time, this creates data sprawl, and the data scientist has trouble recreating the results because she can't find the correct data set that she used. So what can we do? What can we do to address this, and what can we do from a storage perspective? Well, there is a use case called cloud bursting, which is when you have an application that traditionally defined it's running in a data center or private cloud, one of these core sites. But in our case, it's running on an edge environment. And from any of those sites, you can rapidly scale your compute, your storage, or your memory by bursting, or in other words, moving your workload into the public cloud if it needs more resources. And you can do this for performance, such as the case with our data scientist, or you can do this for additional capacity. And so the advantages are performance, like in our data scientist case, or cost, where you only pay for the additional resources when there's a demand, or even availability to avoid interruption of service if you have spikes in your business workload. And cloud bursting isn't really an emerging use case. It's been around for a while, but the extension of cloud to edge as a hybrid cloud location seems to have given it a little bit more traction, along with the trend to edge computing and maybe this thing called a pandemic that forced a lot of enterprises to do digital transformation. So we're seeing cloud bursting, come alive, so to speak. And so how can storage help with cloud bursting, right? So here again, we have our edge site on the left, and we have our core site on the right. And this time, the data scientist still has to go get approvals from data governance and still has to find a place to run her workload. But maybe she only has to do this, one time, since the data will be moving to a consistent location, which is secured and controlled, right? So then the storage admin creates a cluster with a single namespace, such that when a file is referenced on the edge or core, the storage layer replicates it, seamlessly serving it to the application or user as if it were local to that site. So when the deep learning application references the data on the core site, the storage layer prefetches the data across this single namespace. So then, as before, now she trains her model, and as before, it's 8 or so times faster because she's using a GPU. And then when the model's created, it can also be seamlessly pushed back to the edge, again, if it's running over this architecture where single namespaces are set up. As well, over time, the storage can evict data that hasn't been used recently. So the value this provides, that storage can provide, is a single source of truth for your data, which can also free up the data scientist to focus on the data science work.
Erin, a question on that. Does that create, you mentioned latency issues moving from edge to core. Does this create latency issues the other way, where the core is actually looking for data that's stored on the edge and has some latency issues as a result?
Well, if you're talking about the prefetch, I mean, I guess it would depend on how frequently the data is referenced, right? And what sort of networking that's working across. And so that's a possibility, right? But it's true that, you have to look at all the use case specific to your industry to know if any latency that's part of any aspect of this flow would be acceptable to you, right? Because this also wouldn't be an industry 4.0 case, most likely, right? Where you need very low latency on the edge site. So for the core, maybe it's okay because if, in the overall timeline for training that it's getting reduced because you're getting rid of all these manual steps, that little bit of latency might not make a big difference when you're looking at, training when compared to training a model.
Mm-hmm. Erin, in the third patterns, we actually will talk about. We actually will give some hints about how this is implemented. I think that latency is a good question, and Erin answered the questions. Answers is correct. But I think that there are a lot of elaborate technology can smooth these things out, and we'll talk a little bit more on that section.
Yes, thanks, Vincent.
Okay, and there was another question that came through that I think is relevant. It's related to the big word today, heterogeneity of the devices. So heterogeneity means basically the variability of the devices. One being a GPU and one being perhaps a non-GPU workload. Does that cause a challenge in terms of edge computing or in terms of sharing the models?
So when you said heterogeneity of the devices, I thought about edge devices and not these edge servers. I'm wondering for the question which they meant. But I think I also might address the heterogeneity of devices as they relate to the way the data is stored in the next use case. So I think we can pause that, and then if somebody wants to clarify their question there to further answer which aspect, if we don't answer it, then we can come back to it. Sound good?
Right. Good.
Okay. Any other questions on this use case before I move on?
I think we're good.
Okay. Oh, actually, because I didn't finish this use case. So to summarize for cloud bursting, these are some of the data and storage considerations, if you're looking at implementing a data and storage use case. So we talked about data replication. I mean, you want to be able to move the data with the applications seamlessly, but you do still need to consider data locality and compliance, but that's what your governance team should help with. And even though this cloud bursting example, it's sort of, the application kind of went from the edge to the core, there are cases where with cloud bursting, you have pieces of your application running on both sites at once. And if the application is stateful, you do need to ensure data consistency. Additionally, you have to protect your data. The data needs to be secured across locations if you're making, copies of it, and you need to think about data in transit and data at rest. And in the use case, we had an example around data eviction. So the storage layer can certainly help if it can manage that once the data is used and no longer needed, clean it up. And finally, efficiency, how to do all of the above with the least amount of human effort. Okay, so now we'll discuss another data pattern that we are seeing. So slightly different than the prior scenario. Let's say today that you have multiple edge sites and you want to build a machine learning model that represents the data from all of these edge sites. So what usually happens today is inferencing for machine learning occurs on the edge with training occurring at the core site. And data gets copied from each and every edge site because you want the model to represent data from all edge sites, right? And so then the model gets trained at the core. And then the new model gets pushed back to all the edge sites and inferencing occurs on the new data with the new model at each of the edge sites, right? So you're probably saying, well, how can I build a machine learning model for all of that data without moving it to a centralized location? I mean, I have to move it, don't I? Well, not exactly. Maybe you are in a situation where you can't move it due to regulatory reasons. So what can you do? Another emerging use case is federated learning. And this is where you do some training on the edge as well as the core site. So let me go through what typically happens with federated learning. So there's an initial model that's created and trained somewhere. And in our example, we're training it on the core site. And then just like the previous example, the new model gets pushed to the edges and inference occurs on the new data at each of the edge sites with the new model. But now what's different is on the core site, you have an aggregator process. And this aggregator process goes and requests a retrain. So for each of the edge sites, it says, go retrain the model you have, the copy of the model that you have, using the data that only you have. And so the models are retrained on the edge. And then the aggregator pulls the model updates from the edge, the updates, not the raw data, but just the model updates. It collects those and it can retrain just using the model updates. And then once it creates that new model, it redistributes it back to all of the edge sites. And the value of federated learning is that it allows you to improve your model training across locations without moving the raw data. And this can help address data privacy, locality, and security concerns. This can help you adhere to regulatory compliance. This can help you tackle data volumes at lower cost. And this is slightly different than the deep learning cloud bursting case where the application was only running on the core when it had to perform training. Here, the application spans both edge and core, and there's some coordination that's happening. But the application itself, in a lot of these cases, right, usually contains the logic to move the data. Maybe it's doing an SSH tunnel with a secure copy. But, however, if it were handled at the storage layer, that could simplify application complexity and improve time to market for anybody building a federated application. So how can storage help with federated applications such as federated learning? So here's an example where, let's say we have multiple edge sites, and speaking to data heterogeneity, we have data that's stored in different file type, like file protocols, right? File, block, object. Here, one way storage could help is, so as I mentioned, the application itself contains logic to move the data across the sites. Like today, it's not counting on anything underlying in the storage layer to help it along. And so the application is doing the data movement. In addition, it probably has logic to support heterogeneous data across multiple access protocols, multiple protocol interfaces. But what if instead we could provide that support in the storage layer? For example, one way storage could help is by virtualizing multiple protocol access. So for example, if you could ingest object storage through the file interface without making an explicit copy, that can enable data sharing between the workloads. And then similar to the considerations for cloud bursting, again, we have this single namespace. In this case, it becomes important because the application is distributed and it wants to reference the same data. So now instead of the application creating an SSH tunnel to do a secure copy and itself managing the data movement, it can write to the file system. And now the storage subsystem would do the predefined replication for them. And the value of this is it allows you, just like with cloud bursting, to move the data with the application seamlessly, but then also provide access to data regardless of how it's stored. So now I'll turn it over to Vincent to discuss the third data movement pattern.
Okay, okay, thank you, Erin. So Erin talked about two use cases. The one is more like moving the data to where the core compute capability that GPU is. The other one is sort of moving the application to where the data is. And we talk about where storage play a role in both cases. Now we're going to talk about mesh everything together. And in the case of imagine a customer that need to harvest the insight from all the data everywhere. Could be some in edge, could be some in cloud, and they have to merge those data together. They have to get the full view of the insight from all the data. So obviously, a query engine to access the data in the local storage, that's very fast. There's no questions. But that is only partial data. In order to get all the data, they need to, in order to access, get a full view of the picture, they need to get, the data from other sources. And there's data sources can be in the relational databases, can be in HDFS, can be in raw object storage, and can be in on-prem data centers, and could be in the cloud. And now you see the problem. And previously the gentleman asking about the latency. Yeah, now this is the problems. When I try to run the query engines, right, I try to be able to merge and catalog and manage all the data together. And I have this asymmetry of the data. Some data is very fast and locally, some data is very far, and I have all kind of different different attributes, different access patterns that create a lot of challenges for people, for customers. Today, they have to sort of segregate the data, try to run the query engine on particular data sets, and try to merge them together. So I think that the industry trend is have one sort of a query engines be able to query all the data regardless of the location type, and that's where the storage come in, and that's where we think that the storage, next generation of storage virtualizations will satisfy that requirement. Erin, if you can go to the next page. So the concept here is creating this intelligent data caching and virtualization to allow the applications to be able to access data, make it heterogeneous data appear to be homogeneous to application, regardless where the data type and regardless where the data location. This data virtualization need the storage virtualizations technologies. So there are a lot of elaborate, caching capabilities, injection capability technology to make sure that we can cache the data at the right place, at the right time to facilitate this operations. And then there are more, intelligent building that we can even predict, when you're going to access those data across the entire infrastructures. So this is the next generation of the storage virtualization is no longer just making the block storage, various different type of block storage, appear to be the same. This is making the various different heterogeneous data appear to be homogeneous to the applications. Okay, Erin, get back to you.
Okay. So in summary, these are some of the emerging edge use cases we've been seeing that are driving different patterns of data movement that may impact your storage strategy. We talked about cloud bursting, where the application itself moved from edge to core and logically back, although in the bursting case, it probably just got deprovisioned on the cloud. We talked about federated learning, where the application spans both the edge and the core, and data needs accessed from both sides. And we talked about the query engine, where basically the application could run anywhere. It could run on the edge site, it could run on the core site, but it can quickly access data everywhere. And Here's a summary of some of the storage features you may want to look for when deploying workloads across Edge and Core. So, Vincent just talked about the intelligent data caching and virtualization, which can help with latency problems. We talked about virtualization across multiple protocols. And then we also talked about a single namespace, which can help create a unified data fabric. And there's one other consideration to think about if you're making storage software choices, and that's your deployment consideration. Storage features that are containerized are more likely to be portable across Edge and Core. So for each of these features, you might want to look and see how are those being deployed. And what these features give you, the value they provide, is a single source of truth for the data, as well as fast access to data, regardless of how it's stored and where it lives. And with that, I think we can turn it over to any questions.
Yeah, so there's a couple of questions. Let's stay on the slide and address a couple of things. I'm going to take them a little out of order. The first was when you were talking around especially the federated model. You talked a lot about moving your models back and forth, or basically updating new models out to the edge from the core. Can you speak a little bit to the version control that you would need to implement? And could you envision a scenario where you'd actually have different edge units running different versions of the model?
So what a single namespace gives you is that you wouldn't have to have different file versions, so to speak, unless the question is around whether or not people want to run with different versions. In which case, I think that would be, again, handled probably through the federated application. And then from a storage implementation, thinking through it, they would probably, you might have different policies set up for the replication across Edge and Core, depending on how you set up that single namespace, right? So you can set up a single namespace such that it goes only in one direction, and you would do that based on, directory mount points, or you could set it up where both sides could write to a file in general. And Vincent, I don't know if you have anything you want to add to that.
Yeah, I think that your answer is right on, and let me just add a little bit more. Right, so it's conceivable that multiple edge devices will run different version of the same file, and that's where all about this version control. The single namespace give you the flexibility. Think about it today. How do people do that? People make a replica of data and create their own version, and then just completely lose track of which file is which version at what time. And with this single namespace, single data fabric, allow you to be able to, even you create a version, at least those versions are known versions, and then they are consistently managed by the entire clusters. So let's say the edge device is running version 1, edge device 2 running version 2, but at least the whole picture, whole cluster is aware of this file has multiple versions, and that's all go back to the in the world of the hyper cloud, between the core and the edge, the data management part is the crucial element, the crucial technology for your success.
Mm-hmm. There's another question that comes in that I think is a good one. Are we making any assumptions about the wide area network bandwidth when we're building this out? And the point was made that even when caching data locally, the transit time for large amounts of data or large amounts of metadata could be pretty prohibitive. So can you speak a little bit to how you manage some of the bandwidth considerations, especially where the bandwidth might be variable depending on your edge?
Yeah, so let me take this one, Erin.
Yep.
So very good questions, and the WAN the bandwidth is absolutely important topics. So how do we address that? So first of all, that you need to have the WAN management, the prioritizations, and the technology they call the WAN acceleration technology, to make sure we prioritize the particular workloads to guarantee the quality of services. Those things need to be planned. Just because we think that those capabilities available, be able to caching data back and forth or caching the model, doesn't mean all problems are solved. So this is a very important problem, and I think that the connections, the integration with software-defined storage or software-defined network together to address this problem is crucial. Erin, I don't know, do you have anything else to address?
Nope.
Okay.
I was just going to bring up SDN too, so
Yeah.
you covered it.
Very good.
And what about the case where the connectivity is not guaranteed? You mentioned that early on, Erin, in terms of, you might not always have reliable connectivity from one place to the other. Does that cause a difference in some of the use cases that you would do? Or, or more to the point, if your data is not available, does that change the concept of your single namespace or your single unified data fabric?
Well, yes, so I think if your use case requires disconnected operations for some point in time, then you need to be able, if you set up a single namespace that, it has features where, it either retries again and detects a failure, so to speak. The interesting thing about Edge and the frustrating thing about Edge is the environments are so vastly different depending on industry, right? So I think you need to look at your use case and decide what is tolerable, and then see if even the software layers in a federated application use case can handle whether or not it's disconnected. It might be that software can't even handle such a disconnected amount of time. So it's a stack problem, really, unfortunately, not just the network, because the software needs to support that too with retries. So yeah, you do need to consider that. And like Vincent said, we're not making assumptions that the underlying network is always there and perfect. But I think you have to look at those on a case-by-case basis with your use case. And I don't know, Vincent, if you have anything to add.
Yeah, so this is one additional things that that's what they put such a premium on the storage layers. So I think that many edge devices does have the requirement that they can run standalone when they are disconnected. But once they're connected, the storage fabric need to resynchronize those data to make sure that bring back the view to be a single unified view. And that is a very 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 advanced technologies. But I think that in this world, when data fabric need to be connected and need to be able to ability to connecting all this endpoints and the cloud, and that's why we believe that the storage technology provides such a premiums to support this kind of configurations.
Mm-hmm. Now, the question here, I think we've addressed some of this already, and I'm going to reword it slightly. But a lot of the assumption that we're making is that the main compute node will be likely cloud based, or the main core will be cloud based. But there's the hypothetical brought up here is a situation where the data resides on prem, and the machine learning tools are in the cloud to build the model. So the goal would be not to move the data, and the question cites security, but it could also be some type of regulation as well. So how do you handle the case where you don't really want the data in the cloud, you want it only on prem? Do you have to do the model on prem as well, or can you get enough information to actually do it at the core?
So I specifically chose the terminology for core to include IT data center. It doesn't have to be cloud.
Okay.
And so, federated, they're federated, and just because you're a container and you're container native doesn't mean you have to run in cloud, right? So even if your federated learning application happens to run in containers, you can still run it in your IT data center if you have an environment where you can run containerized workloads, right? I tried to keep the storage features today separate from specific hybrid cloud capabilities, but I specifically defined core and tried to make a point. I intentionally didn't say cloud because I wanted it to be clear, that core could be IT data center, private cloud, hybrid cloud, or public cloud. Now, I recognize that the term cloud bursting confuses that, but that's an industry term, so I stayed consistent with that. But there's no reason from any of these storage features could be the same features that you connect an edge site to an on-premise data center, an IT data center.
Okay. And you talked Talk a little bit more about the containerization. I mean, you kind of threw it in at the end there, and I think that is a point that we really don't want to lose, the ability to actually containerize some of these models and some of the storage features. Can you talk to some of the advantages of that just a little more?
Specific to containerization in general, or storage specifically?
Storage specific would be probably the best way to go with it.
So Vincent, I don't know if you want to take that?
Yeah, let me take this one. So Erin, mentioned in the use cases that Erin mentioned, right? You look at that storage is running everywhere, and in the past, that storage has a very, be honest with you, that for the decades, right, storage has a lot of kernel module and things like that. Is make it sort of like only suitable for the particular environments. But I think that in order to support this hybrid cloud environment, the use cases that Erin is talking about, that we need one requirement, one core capability is making storage capability portables. They can port this storage capability on the cloud, on a core data center, and the edge devices and endpoints. And that's where the containerization becomes so important, that we can containerize the storage capabilities and then be able to run it in multiple places in these spectrums, and they can collaborate with each other so they don't create storage islands. So that's what Erin talking about. All this vision that Erin talking about, the containerization really is the core technology to enable it.
Mm-hmm. Okay, and we have one final question, and it's a little bit more generic, but I think it's a good question, and I think you'll be able to make a couple good points with it. The question, as written, was: can we say edge computing is an opposite of cloud computing? Edge is part of cloud computing, I would think, but I'd be interested in your answer for that.
Yeah, so I mean, we tend to position edge. And people can have different views, right? But we tend to position edge as an extension of hybrid cloud and take advantage of, cloud functionality that can be delivered on an edge site, because it can just make it more seamless for an end user and have a consistent interface and a consistent experience. And by the way, a lot of edge sites don't have IT skills. So the more you can simplify that, the better it is. So we view edge as just a participant in a hybrid cloud infrastructure. But I can see where certainly that's not a required viewpoint for a lot of use cases in industry verticals, and there's certainly other things you can do outside of cloud. But I don't know, Vincent, if you have thoughts.
Yeah, so this is a good debate here. I think that there's really no wrong answer or right answer, but I think that what I see is this is really the line between the edge computing and cloud computing is really blurry right now, and getting more and more blurry, right? We can see that in the future, that multiple edge devices form their own sort of cloud, that's sort of loosely coupled cloud, and it's different from the traditional or definition of the cloud computing. So these things, the reason why it is so hard to give a definitive answer is these things are both of them are evolving very very rapidly, and in my opinion, my humble opinions, I think the line is blurry, and I think that those distinguishes is less clear, going forward.
Absolutely. Mileage always varies in the computer world, because things change so fast. But I think it's fascinating to see even how much it's evolved over the recent years with some of the discussions that we've had here. And I think this is a really great introduction to some of the edge storage considerations. We could talk about this for hours and days after this as well.
Mm-hmm.
I certainly want to thank Erin and Vincent for participating in this and for providing so much insight to all of us. I certainly learned a lot, and I thank you for that, Erin and Vincent. I'd like to thank the audience as well for viewing this webcast. Please make sure to rate and provide us with feedback. We like the ratings, and that's always good, but we also want to know from your feedback, what are the things that you'd like us to address in the future? We at SNIA are very good at driving a series of talks, and so if there's more things that you'd like us to pursue on edge storage, we would be happy to do that. Please provide us that in the feedback. This webcast and a copy of the slides will be available at the SNIA Educational Library, and you can see the link there, snia.org/educational-library. There's a fascinating amount of content in that space. And I think there's some great container webcasts that we've done as well, if you want to learn more about containers that we just touched on here. And like we said earlier, a Q&A from this webcast will be posted at the SNIA Cloud blog, and you can see that there, sniacloud.com, and you can follow us on Twitter at SNIA Cloud. I certainly appreciate all the time that both the presenters and the audience have provided to us, and I look forward to seeing you on another SNIA webcast. Thank you very much. Have a great day.